Questions 1 through 10 on the 2003 Grade 8 AMC 8. Jamie counted the number of edges of a cube, Jimmy counted the number of corners, and Judy counted the number of faces. Then they added the three numbers. What is the resulting sum? In any cube, the number of edges is 12. In any cube, the number of corners is 8. And the number of faces in any cube is 6. So if you add up these numbers, you'll get 26. So number 1, the answer is E. Which of the following numbers has the smallest prime factor? So 55, if you were to break it down into its prime factors, it would be 11 times 5, basically. 57 is 3 times 19. 58 is 2 times 29. 59 is a prime number itself, and 61 is also a prime itself. So if you look at these individual prime factors, 11, 5, 3, 19, 2, 29, 59, and 61, what they're asking is which one of those is the smallest. And of course, the smallest among all those numbers that I underlined is 2. And therefore, 58 contains the smallest prime factor. So number 2, the answer is C. A burger at Ricky C's weighs 120 grams, of which 30 grams are filler. What percentage of the burger is not filler? So 120 grams, 30 grams of that are filler, whatever filler means. I'm assuming that's not meat. And then the remaining 90 is meat, most likely, hopefully. So that means what percent is not filler? So 90 over 120. And that would be exactly 75%. So number 3, the answer is D. A group of children riding on bicycles and tricycles rode past Billy Bob's house. Billy Bob counted 7 children and 19 wheels. How many tricycles were there? Well, I am assuming that this photo is kind of confusing because it shows no kid on that bike, but I am assuming that all the bicycles and tricycles are being ridden. Otherwise, how can the bicycle or tricycle go by his house, right? It can't ride itself. So that means that the number of bicycles and the number of tricycles is 7. All right? Each child is on one vehicle. So B plus T is 7. And then we know that for a bicycle, there's 2 wheels. And then for a tricycle, there's 3 wheels. And the total number of wheels, they tell you, is 19. So there you go. You've got 2 equations, 2 variables, and we can figure out either of them. From the first one, you can isolate for another variable. So since we're interested in T, I'm going to isolate for T. So B is equal to 7 minus T, like that. And then I can substitute that into there. So we got 7 minus T plus 3T is equal to 19. 14 minus 2T plus 3T is equal to 19. And therefore 14 plus T is 19. And therefore T is equal to 5. So there's 5 tricycles. And therefore number 4, the answer is C. If 20% of a number is 20, what is 30% of the same number? So 20%, 0.2, of a number is equal to 12. So that means x is equal to 12 over 0.2, and therefore x is equal to 60. And now they want 30% of the same number. So 0.3 times 60, and that would be 18. So the answer to number 5 is B. Given the areas of the 3 squares in the figure, what is the area of the interior triangle? So since these are squares, they've given you the areas there. The side lengths, basically, of a square would give you the formula x squared equals the area, like that. So for example, if this was x, 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 and x, the side lengths, x squared would be 144, correct? So x is equal to 12. So this is 12 basically. And similarly for this square, we'd have x squared is equal to 25, and therefore x in that case is 5. So this is 5, and so on. Now they want the area of this small triangle inside like that. Well, no problem. The area of that is 1/2 base times height. And the base is 12, and the height is 5. So we've got 12 times 5, which is 60, divided by 2, so the area is 30. So number 6, that would be B. Blake and Jenny each took 4 100-point tests. Blake averaged 78 on the 4 tests. Jenny scored 10 points higher than Blake on the first test, 10 points lower than him on the second test, 20 points higher on both the third and fourth tests. What is the difference between Jenny's average and Blake's average on these 4 tests? So I'm going to let Blake's scores be A, B, C, and D on those 4 tests of his. And we know his average is 78. So that means A plus B plus C plus D divided by those 4 tests is 78. So A plus B plus C plus D is equal to 4 times 78, like that. Okay? And now we turn our attention to Jenny, and she basically has scores that are related, 10 points higher than Blake on the first test. So that would be A plus 10 on the first test. On the second one, 10 points lower, so B minus 10. On the third and fourth test, 20 points higher, so C plus 20. And D plus 20, like that. All right? And yeah, so we have to now figure out her average. Her average would be, add them all up. So A plus 10, B minus 10, plus C plus 20, plus D plus 20, like that. All divided by 4. And this gives you A plus B plus C plus D. Let's see here. The 10 and the negative 10 cancel, and then we get 20 plus 20, so that's 40 over 4, like that. And then this guy right here, A plus B plus C plus D, we know is 4 times 78, like that. Just put that in there. And then this looks like we can cancel the 4's, so 78, and then 40 divided by 4 is 10, and therefore 88 is Jenny's average. And they want us to figure out the difference between Jenny's average and Blake's average. So Jenny's average is 88, Blake's average is 78, and therefore the difference is 10. So number 7, the answer is A. Problems 8, 9, and 10 use the data found in the accompanying paragraph and figures. Bake sale. 4 friends, Art, Roger, Paul, and Tricia, bake cookies, and all cookies have the same thickness. The shapes of the cookies differ as shown. Art's cookies are trapezoids, Roger's cookies are rectangles, Paul's cookies are parallelograms, and Tricia's cookies are triangles. Each friend uses the same amount of dough, and Art makes exactly 12 cookies. Number 8. Who gets the fewest cookies from one batch of cookie dough? All right. We are not told how much one batch is in terms of its amount. So we will need to give it a number. So I'll give it a number later. Let me just first figure out the areas here. The areas. For Art, this is a trapezoid? Well, yeah, it tells you that. So the area of a trapezoid is A plus B over 2 times height, right? This is A, this is B, this is height. So that looks like 3 plus 5 divided by 2 times 3. So this is 8 over 2, which is 4 times 3, which is 12. So that's the area of one of his cookies, all right? And inches squared, inches squared. Roger, it's just a rectangle, so that area is pretty straightforward, 8. The parallelogram, same thing, 2 times 3, so that's 6. Triangle, 1/2 base times height, so 4 times 3. So 12 divided by 2 is 6. So these are the areas of each cookie. Now we want to figure out who has the fewest cookies in one batch. So one batch, we are not told what is the size of that batch. So I'm just going to call it a certain amount. One batch, say, is, I don't know, 24, let's say, square inches. Okay? If that is the case, how many cookies will each of them make? Well, if 24 is in one batch in terms of its amount of cookie dough, and each of Art's cookies is 12, 24 divided by 12, 2 cookies in each batch for Art. And very similarly for Roger, it would be 24 divided by 8, so 3 cookies for him, 4 cookies for Paul, and 24 divided by 6 is another 4 cookies for Trisha. So who gets the fewest cookies from one batch of cookie dough? Fewest cookies looks like Art. So that would mean 8 is 8. Moving along to the next question, number 9. Art sells cookies for 60 cents each. To earn the same amount from a single batch, how much should one of Roger's cookies cost? All right, so in our scenario number 8, Art had 2 cookies, right? And each of these he's selling for 60 cents. So that's $1.20 for his 2 cookies, correct? Now we want Roger. How much should he sell each cookie for if the total amount is the same? For him, from one batch, we figured out 3 cookies. So 3 times the price, let's say. So price has got to equal $1.20 because they're saying he has to earn the same amount from his cookies. So that means the price is $1.20 divided by 3, which is 40 cents. So 40 cents, 9 is C. And then we get to number 10. How many cookies will be in one batch of Trisha's cookies? Okay. And in my example, she bakes 4 cookies. But 4 is not one of the answer choices. And the reason is because this is not how much dough is in one batch. I just made it that just to kind of, do number 8. So how do you know how much is in one batch? Well, we kind of do, we kind of don't. The question doesn't directly tell us, but they do tell us this. Art makes exactly 12 cookies. All right, that's a big clue. If Art makes 12 cookies, that means everybody else apparently has the same amount. They tell you that everybody's got the same amount of dough, and Art makes 12 cookies with his. So if you look at this comparison right here, in this one, in number 8, Trisha made twice as many cookies as Art, right? So basically what that means is regardless of what the dough size is, Trisha's always going to make twice as many because her cookies are half the size in terms of area. So if Art makes 12, Trisha makes 24 cookies. All right, that's just a very straightforward way of looking at it. So number 10, the answer is E.